Today in pre-cal we started a new lesson called Pythagorean Identities, and this topic is based on the idea of Pythagorean theorem as it applies to some trigonometry. So starting with the first section, we need to just copy down some formulas that we need to memorize eventually. Actually, I will be giving you a sheet that you can use on your exams that will have all of these things included. So you won't have to memorize these, but you will use them so frequently that it will feel like you have memorized them. So that's the first. Sine squared plus cosine squared equals 1. The next is 1 plus the tangent squared of theta equals the secant squared of theta. And the last is 1 plus the cotangent squared of theta equals the cosecant squared of theta. And those will become important as we start to solve. This is just a different way of thinking than we've looked at before. We're going to look at two examples. The first one is that we're given that sine of theta is 1/3, and we're in quadrant 2, and we want to find the cosine of theta using our identities. So not using any methods we've previously learned, but instead using those identities. To do that, we have to figure out one that relates sine and cosine. That's that first one, so let's go ahead and copy that down. Sine squared theta plus cosine squared theta equals 1. The sine squared, or the sine, is 1/3. So we're going to plug that in for sine and then put the squared. Plus cosine squared theta equals 1. Now off to the side, let me just show you real quickly a notational thing. The sine squared of theta is the same as saying the sine of theta and then all of that squared. The reason we don't write it this way is that the sine of theta squared implies that the theta is what's being squared, not the whole sine. So this is how we write it. When we plug in for sine, we put in our number and then square it. Coming back to our problem, then we can square 1 squared is 1, 3 squared is 9, plus the cosine squared of theta equals 1. To get cosine by itself, I'm going to subtract 1/9 from both sides. I might need to review a little common denominator here. 1 is the same as 9/9 minus 1/9. I just subtract my numerators, so my cosine squared theta is the same as 8/9. Okay, I'm just moving over here. Now to get cosine by itself, I'm going to take the square root of both sides. On this side I have the cosine of theta equals the square root of 8 over the square root of 9. The square root of 9 is 3. The square root of 8 is the same as 2 square roots of 2. Remember, those are those rules where I can simplify. 4 times 2, the square root of 4 is 2, and so there's a 2 on the inside. And the last thing I need to do is, knowing that I'm in quadrant 2, so just kind of visualize here, my x value is negative, my y value is positive, cosine is an x, so this is a negative value. I'm going to use that to figure out my sine. Now, I'm not just pulling that negative out of nowhere. Where that's coming from, remember when you do square roots, you're technically doing plus or minus that number. That's where this is coming from, and in this case, we're talking about the minus. Let's look at one more example. Number 2. The secant of theta equals -9/4. We're in quadrant 3, and we want to find the tangent of theta using only our identities. The property that goes along with this is the one that relates tangent to secant, and that's 1 plus tangent squared of theta equals secant squared of theta. And for secant, I'm going to put in -9/4, square it, recopy everything else down around it. -9/4 squared is positive 81/16. Then I'm going to subtract 1 from both sides, and I have the tangent squared of theta equals, this is like doing 81/16 minus 16/16, which is 65/16. Again, that's just some fractional stuff. Hopefully you remember that. Take the square root of both sides. And so the square root of 65 over the square root of 16, which is 4. And then I just need to figure out my signage. We're in quadrant 3. Quadrant 3, we have negative, negative, x and y. Our tangent is y over x, so a negative over a negative would be a positive. So my tangent would be positive, and that's my final answer. The assignment that goes along with this is A2. It's page 319, 59 to 62, just a few short problems to kind of expose you to this. Do those and let me know if you have questions.